We're taking a break from some geometry, and we are reviewing, or in some cases maybe learning for the first time, some algebra of solving systems of linear equations. There are three ways to solve a system of linear equations. I'm going to talk about each of the three. There are more than three. There are three sort of common ways. Before we get into the three ways, we're going to define a system of equations. It is a set of two or more equations with the same variables. The solution to a system of equations is the set of values that makes all the equations in the system true. And by true, we mean that when you plug in the solution, you get a true statement. One side of the equation equals the other. The first method of solving a system of equations that we're going to talk about today is the graphing method. The solution of a system is the point of intersection of the graphs of the equations. In this example, we have two equations, a system, y equals 2x minus 7, which is this line, and y equals negative 3x plus 3, which is this line. On the calculator, I graphed both of those, and I've used the calculator because the calculator will graph it exactly. Graphing by hand, obviously where you're drawing it, can be inaccurate. But once I graph the two equations, the point of intersection of the two graphs is the solution to the system. Now, sometimes that point of intersection is very clear. You can just look at it. In this case, it looks like that's the point 2, negative 3. Because that's pretty clear. But if that point is not clear, you can go through the function on the calculator of calculating that point of intersection. Once you graph the two graphs in your y equals, then you do second trace on your calculator. You can take a look at it right now. Second trace. And one of the options says intersect. You choose that option, and the calculator walks you through a couple simple steps to finding the point of intersection of the graphs. And that point will be exact. There will be no ambiguity in finding that point. The second method of solving a system of equations that we're going to talk about is called the substitution method. And this is very algebraic. It's called the substitution method because we are going to literally substitute one equation into the other equation. So in our example here, 3y equals 12x minus 21, and 12x plus 2y equals 1. In order to substitute one equation into the other, we have to solve one of the equations for one of the variables. Now, looking at these two equations, it looks to me like solving the top equation for y would be the simplest algebra. So if I have 3y equals 12x minus 21, and I divide both sides by 3, I get y equals 4x minus 7. Now the next step is to take what y equals and plug it into the other equation for that y. So this equation now reads 12x plus 2 times y, which is 4x minus 7, equals 1. This gives me a single equation with a single variable, which means I can solve for that variable. If I distribute the 2, combine like terms, add 14 to the other side, and divide by 20, I get x equals 15 twentieths, or 3/4. Now that we have solved for x, we can find the y value. Take what x equals and substitute it into one of the original equations for y, or excuse me, for x to solve for y, or better yet, substitute it into the equation that you already have solved for y. This will be the easiest thing. Y equals 4 times 3/4 minus 7. For those of you that like to use decimals, you can't cancel the 4's like I can. So I can easily see that y equals -4. So the solution to my system of equations is the point 3/4, comma, -4.
Yes, understanding.
The third and final method of solving a system that we will talk about is called the addition method, also known as the elimination method. It's called the addition method because we're going to add the equations together. It's also called the elimination method because we are going to eliminate one of the variables. Right? The name tells you exactly what to do. Alright. When using this method, the first thing you should do is line up your terms. And this is what I mean. Those are both A terms. Those are both B terms. Line up your equal signs and line up your constants. Now, of course, your variables might not be A and B. They might be X and Y. They might be M and N. Whatever it is, it doesn't matter. Line them up so that they correspond to one another. The reason you need to do this is because we are going to multiply one or both equations by some number or numbers to eliminate one of the variables. As I look at this example, B is the easiest variable to eliminate. Because if I multiply this equation by -2, this positive 30b will become negative 60b. And it'll eliminate the b's altogether. So let's do that. I'm going to first rewrite the top equation. And now I'm going to rewrite my new bottom equation. And you can see that the b's are going to cancel out. So the next step is to add the two equations together. I get negative 260A. The b's are gone. Do not write 0b. Okay, I've seen students do that. It confuses them. They think the b still exists. It does not. It's completely gone. Bring down my equal signs. Negative 130. Now I have a very simple equation to solve for A. Divide both sides by negative 260, and I get 1/2. Now that I know what A is, I'm going to plug A into either one of the two original equations and solve for B. There's my equation with my A equaling 1/2. I get 70 plus 60B equals 40. Subtract 70 to the other side. I get 60B equals negative 30. Divide both sides by 60, and B equals negative 1/2. So the solution to my system of equations is the point 1/2, comma, negative 1/2. And of course we know A comes before B, just like x comes before y. So I put the a value first and the b value second.